Assalamualaikum and hi to our lecturer Madam Zurina binti Syamsuddin and also our client. We are from JJRNS company, want to present and also consult our client regarding our finding on stainless steel mechanical properties and its structure. Me myself Rosida not doing this finding alone, where I also got helps from other team members which are Siti Hazika, Nur Hanis, Nurul Iza and also Khairina Naziha. I will introduce my team members and their tasks. Siti Hazika will present the problem statement and the objective, while Nur Hanis will present about the technical findings. Other two members, which is Iza, will present the relationship between microstructure and the mechanical performance. And lastly, Harina will conclude all the findings of our task.
My name is Siti Hazika and I'll be stating the problem statement and objectives of this project. So the problem statement of this project is to study the connection between the structural properties and tensile behavior of 316 LSS and the cold roll 316 LSS that can be used as structural materials for Petronas Twin Tower project. There are three main objectives that we can achieve throughout the project, which include identify the standard procedure of tensile testing, which give us the tensile properties, and next we can analyze the relation of tensile properties and microstructure between the 316 LSS and the cold roll 316 LSS. And lastly, we should be able to apply the knowledge of material properties of 316 LSS to improve its properties.
Hello, I'm Hanis, and the technical findings is that the difference between these two specimens can be observed by performing two separate tensile tests towards the original and the cold specimen of 316L stainless steel. So from the graph we can obtain that the tensile strength from the maximum point of engineering stress, which is about 563 megapascal and 974 megapascal for the original and the cold rolled specimen respectively, while the fracture strength can be obtained from the value of stress at the point of rupture, which here can be seen on the slide. Yield strength, however, is obtained from the intersection of the curve with the line parallel to the initial slope of the curve at 0.2%, which here we have obtained the values of 257 megapascal and 676 megapascal. These are the graphs that shows the slope to obtain the yield strength, which is also known as the modulus of elasticity, obtaining values such in the slide. The cold roll specimen, however, seems to have obtained a lower ductility percentage than the original specimen, which is at 1.96% against 22.12%.
Hello, my name is Iza and I will present about the relationship between microstructure and mechanical performance. Basically, there are two samples, which is original and cold roll sample. For both samples has their own differences. Firstly, the original sample has a coarse grain associated with a longer elongation, while the cold roll sample has a fine grain due to the shorter elongation. Meanwhile, for the fracture surface morphology, original sample is high-bit ductile type of failure, but the cold roll sample differs from that of ductile fracture samples, which is ductile and cone type fractures in the case of brittle materials. Next is for the mechanical performance, can be observed that the yield and tensile strength increases, whereas ductility decreases for the cold roll sample, and the cold rolling also enhances the alloy strength. Okay, that's all for me. Thank you.
Hi, my name is Karina and I will be concluding the presentation for today. First of all, tensile testing is an important procedure in order to determine the tensile properties, force and elongation, which determines the stress and strain value. By plotting the stress-strain curve, we can evaluate the mechanical properties of the materials in terms of yield strength, fracture strength, tensile strength, modulus of elasticity, and ductility. In this project, we know that the enhanced method of cold-rolled 316L stainless steel produces finer grain of microstructure and has better strength. It also appears to be less ductile than the original sample. Last but not least is the phase diagram aids in designing new alloys. Thermoplastic bonding, which is a new method to enhance 316 LSS, utilizes the binary phase of materials in order to control the time and temperature of heat treatment. That's all from me. Thank you.